Hey, nice to see you. Well, actually, I don't see you, but nice to. I don't even hear you, but you hear me. You know what I mean. I'm glad that you're here with me. 9.1. We are translating figures and using vectors. And actually, we are not doing that. All that we are doing is translating figures. This section has vectors, and in the past we have done vectors, and we may need to do vectors in the future. Past meaning in previous years. And with you, we may need to do vectors in the future. Most likely we will. I'm almost certain that they are on the FSA. But for our purposes now, please cross out the and use vectors here. Use a vector 2, cross that out. And over in the vocab, you can cross out vector and all that stuff all the way up to, we do want compound and we do want translation. Actually, I'm not going to use compound form, so you can go ahead and cross it out. Okay, so how can I translate a figure is our essential question. And let's start off by looking just at your notes, if you would, please. And a transformation moves a figure from a pre-image, that is the original, call that point P, to its image. So we're going from a pre-image to an image. So it's going from P to P prime. See that little tick mark there, that apostrophe? Let's call that P prime. And that's really important. It's a small little mark, but it means a big amount for us. So we go from P to A prime, but in this case I'm just using the variable or the letter P, and it's being transformed to P prime. Now notice what I've done. When you see that, to think of the letter I and the word image to remind you that the image is P prime. And so you start out with just P, and then you over into the image. Okay, so look at your book. Let me show you an example of that here on page 564, section 9.1. This is a, now let me also show on this too. Transformations is the umbrella term, and there are different types of transformations. See here, chapter 9 is on transformations. The different types of transformations, but are translation, reflection, rotation, and dilation. So right now we're just looking at translation. That's one type of transformation. What am I doing putting the book away? I want the book. And this type of transformation is a translation. So, okay, which one is the pre-image? So what did you do first? Did you do pre-algebra or did you do algebra? Of course, you did pre-algebra. So start with, and then you go to the image. But which one is the pre-image? Is it B or is it B prime? See that little tick mark there? That is the prime. So when you see that prime, you think of the letter I, and that's for image. Okay, so this is the image. And then here is your pre-image. So this big blue quadrilateral here is your pre-image, and it's being shifted over to your image. Think of it this way, that here's my hand, that's the pre-image, and then the shadow, you probably don't see it because the light is in the same place as the camera, but underneath that is a shadow or the image of my hand. You're going from the pre-image of my hand to the image of my hand, from the blue to the E to the B prime. And mathematically, we use a rule of transformation. So x comma y, whatever x and y are, they become transformed to x plus 3 comma y minus particular translation. So for example, a, that is at the coordinates of -1 comma 2, is transformed to A prime, which is 2. Now where did they get that 2 from? They took this -1, plugged it into the rule of transformation, said -1 plus 3, that's 2. And the y coordinate for A prime is 1. Where did they get that 1 from? They took the y coordinate of A, plugged in the 2 minus, and gives you 1. See how that's working? So in effect, what you're doing is you're adding 3 to the x coordinate. So let's look at that graphically. Start out with A. You always just do 1 point at a time. Okay, so ignore everything else. Just look at 1 point. And let's go from A. And how do I get to A prime? First do the x's. So 1, 2, 3. I have to take 3 spaces, go 3 spaces to get over to the right. So that's me adding 3 to the x coordinate. And then I have to down 1 on the y. So I am subtracting 1 from the y coordinate. So there's my 3, adding 3 to the x, and then taking away 1 from the y. So let me, with this first problem that you have in your notes, we're supposed to draw triangle. That symbol there means triangle, RST, with vertices. What are vertices? Well, vertices, remember, are these points. Angle, that's a vertex. And any shape that has an angle like that, it's called a vertex. And then more than one are vertices. So they give us these vertices, and they ask us to find the image of each vertex after the translation. So here is my rule of transformation, and I did not give sufficient room on this coordinate little clipping here. So let's change your rule of transformation and make it minus, if you would please, x comma y minus 2, and that'll allow us to be able to do our translation and still stay on this graph paper that we have here. So there's our rule of transformation. So write out, if you would, write exactly like I have here on my notes, transformation. And remember, translation is one type of transformation. And what is our rule of transformation? It is x comma y goes to x minus 1 comma y, making this the corrected version of this, and writing the same thing down here. Again, if you need to pause the video and copy what I have here, this probably would be wise to be able to do that, so that make sure you understand and you're tracking in what I'm saying in your mind. Okay, don't just don't tune me out. So what we want to do is take 1 point at a time. Remember, I said 1 point at a time. So let's take r, which is at 2 comma 2, and let's transform it using this rule of transformation. So I take the 2, plug it in here for x, 2 minus 1, and plug in the 2 for the y, and 2 minus 2 is 0. So that is, and this is my, now let me ask you, is this the image or the pre-image? Here's the tick mark, which we call prime, and when we see that prime mark, we think of I for image. Okay, so if this is the image, this other dude must be the pre-image. So we start with the pre-image, and we go to the image. So go ahead and plot point R at 2 comma 2, and notice that if I was to do this rule of transformation, I am taking away 1 from the x. So I'm going to the left on the x coordinate, and then I'm taking away 2 from the y, so I'm going down 2 on the y-axis. And so you see now how I go from this pre-image down to the image. So do the same thing if you for point S, and then also for point T. So label those here on the diagram, and then draw the image that it goes to, and there will be some overlap. You get overlap, that's fine, no big deal. And then fill in these other points here of what S prime is and what T prime is. So go ahead and pause the video and do that if you would please. Alright, I'm looking at the next little bit in your book, and it says an isometry. That's how you pronounce that thing. Isometry. I saw. It's kind of like S-A, but isometry. Isometry. An isometry is a rigid or congruence transformation. So we could call it a rigid transformation. This is an adjective. A rigid transformation or a congruence. So what does that mean? Well, the thing stays rigid. it holds still. It's stiff, so that both the pre-image and the image are congruent to each other. What does congruent mean? Let's go ahead and remind ourselves. Congruent, same shape and same size. Another way of saying it is that it preserves both length and angle measures. Both the length and angle measures. So an isometry is a transformation where both the image, or where the pre-image and the image are congruent, where they stay rigid. So in other words, if you were to map this pre-image, for example, onto the image, then they would overlap right on top of each other because they are the same shape. And this transformation does not distort the image, doesn't change the length or the angle measures. It'll be the same thing for a reflection, where it just flips it over. Rotation, all it does is twist the thing. But for a dilation, it makes it bigger or it makes it smaller. So a dilation is not an isometry. Whereas a translation, a reflection, those three are isometries. What shall we do now? Book any useful? This is proving that they're an isometry. Okay, I think we're done with the book. Let me go now to your notes. This is the kind of things that we're going to be doing. So they give us the rule of transformation here. They say the image of transformation is, and okay, it has a bar on top of it, so that means segment. But what's going on here? Well, what are these little tick marks? Oh yeah, that's right. Those are, when I see that tick mark, I think of the letter I. That's image. Okay, so this is the image of segment PQ. So this is segment P prime Q prime, which is the image of segment PQ. And they're telling us that the endpoints P prime is this and Q prime is that. They want us to find the endpoints of the pre-image. No. Here's your rule of transformation. Let's go ahead and write that down. And they're giving us this. This is the image. Oh, wait a second. Backwards now. I have to go backwards from the image to the pre-image. Oh, that's kind of crazy. Let's try to figure out how to do this. If I start with the image at -3, 4, I'm asking what value of x would I need to plug in here, so that if I plugged it into the rule of transformation, I would get -3. Value of x would I need to plug in here so that I would get -3. Hey, so I can create an equation. Let's do that. Let's say x plus 4 equals -3. X plus 4 equals -3. There it is. So now I can solve this equation using simple algebra. So I want to get the 4 over to the line, so I add -4 to both sides. So therefore x equals -7. So what we're saying is, if I was to plug in a -7 here for x, plug that in, -7 plus 4 works. That's -3. Pretty cool. Let's do the same thing for the y. Y minus 7 equals 4, because I'm trying to get back to what y is. So y minus 7 equals 4. And algebra again, add 7 to both sides, so y equals 11. So let's try that. Let's put in 11 here. So if I was to plug in 11 transformation for the y, 11 minus 7 is 4. Okay, it works. So what I did was I went backwards. I started with the image, and I'm going back to the pre-image. You can do that each time. You can make this equation and be able to solve that. But do you see what's happening? Take a look at that and tell me if you can find the trick to it. Well, what it is when you are in the rule of transformation, you just do it normal. You would add 4 to both sides. But when you're going backwards and you have the image and you want to go back to the pre-image, instead of adding 4, what should you do? You need to subtract 4. So you start out with -3, And 4 to negative 3, you want to subtract 4, and that'll give us negative 7. Start out with the image of 4, and instead of subtracting 7, you want to add 7. 7 plus 4 is 11. There it is. So the image, when they give you the image, and you want to go backwards, just do the opposite of what they're telling you to do in the rule of transformation. So the value of Q is what the pre-image of Q prime is, and do that on your own. Go ahead and pause the video. Number 3, they say A prime, B prime, or triangle, A prime, B prime, C prime, is the image of triangle ABC after a translation. And we could have known that. Well, I mean, it's nice to know that it would have been, that they, anyway, just from this picture, we can really tell that. Because we know that when you see the prime, you think of the letter I, this is the image, so therefore B must be the pre-image. So we're going from pre-image up here to the image. And they're asking us from this graph to write a of translation, or rule of transformation for this. Okay? So what you do, you take one point. It can be A or B or C, does not matter. But take one point and follow that point from A image over to the image. So what do I need to do? What do I need to do to A to make it shift and translate over to A prime? Well, count the number of blocks. And not only that, first of all, hold on. How many is each block? You need to figure out how many units is each block. Here's a 6, here's a 4. Okay, so how many units is each block? And then count the number of units from A on the x-axis that you need to get under A prime. And that's the number you would add here. And then, because you're going to the right, correct? You're going to the right, so you're going to add. And then you want to go up a certain number of units to get to A prime. So that's the number of units that you want to add y there. Okay? And that's all you need to do is just fill in the rule of transformation. Go ahead and pause. Then lastly, for number 4, we are almost done. We were told that triangle ABC has these coordinates, and it's translated to triangle A prime, B prime, C prime, with A prime being at -5. So A prime is -5, 2. So, and now they want us to determine the rule of translation. So we can call it a rule of transformation, or in this particular case, it is a rule of translation. So they want us to figure out what the rule of translation is, and to determine the coordinates of the remaining vertices. So this time they're giving us the coordinates. Last time they gave us the graph, and we have to figure out the rule of transformation. Now they're giving us the coordinates, and we have to figure out the rule of transformation. So what I would graph this guy just to get a visual image of what's happening. And here is A, so that's the pre-image, and then down over here is A prime. So what do I need to do to go from A over to A prime? I need to go to number. So when you go to the left, remember you're subtracting. So you're going to be minusing here for your x. And then you're also going down for the y, so you're also subtracting for the y, however many units you have to go down. Make sure you know how many units each block is worth. Okay? So you can do this graphically, but you can also do it mathematically. You can also say, okay, I start out with A, and my x-coordinate for A is at -2. What do I need to do to -2 to make 5 for the A prime? So what do you need to do at -2 to make it -5? And figure out that number, and that should be the same number that you would get graphically. And then with a y, what do you need to do to 4 in order to make it 2? And that should be the same number that you would get from determining, or get. My wife always corrects me. She says, you talk like a southerner, you say get. Well, I am from Missouri, that's where I was born. So maybe, I'm sorry if I'm distracting you, but get, I think, is the right way you say it. So the number that you get from doing it graphically here is the same number that you should get when you do it mathematically. All right, and then once you get that rule of transformation, then use that rule of transformation to figure out, let's change my word here so I don't embarrass myself by saying it wrong, to figure out what B prime is and what is, okay? So that's your job. Okay, hope that was helpful to you, and I look forward to seeing you in class.